Welcome back guys to Mathematical Mindset. So right here guys, we have this nice Math Olympiad problem that says 6 raised to the power of x plus 2 minus 6 raised to the power of x is equals to 60. We are to find the value of x. So guys, the first thing you want to do, you want to recall that from the property of exponents, we have this property right here from exponents that says a raised to the power of m plus n is equal to a raised to the power of m multiply a raised to the power of n. So applying this property to the first side of the equation, we have this to be 6 raised to the power of x multiply 6 raised to the power of 2 minus 6 raised to the power of x is equals to 60. So the next thing guys you want to do is to simply factor out the common term. So factor out the common term, and the common term right here is 6x. So we have this to be 6 raised to the power of x into, if you factor out 6 raised to the power of x from this, we have this to be 6 squared minus, if you factor out 6 raised to the power of x, this is going to become 1, which is equals to 60. So from this, we have that 6 raised to the power of x into bracket 6 squared is 36 minus 1, which is equals to 60. 6 raised to the power of x is going to 36 minus 1 is going to give us 35, which is equals to 60. So the next thing we want to do is to divide both sides by 35. So if you divide by 35, this is going to cancel out this. So we have 6 raised to the power of x is equals to 60 over 35. But we know that 60 is equals to 12 multiply 5, and 35 can be expressed as 7 multiply 5, right? So putting this right here, we have that 6 raised to the power of x is equals to 12 multiply 5 over 7 multiply 5. So this is going to cancel out this. So therefore, we have that 6 raised to the power of x is equals to 12 over 7. So the next thing we want to do is to simply take the logarithm of both sides. So taking the logarithm of both sides, we have that this is to be 6 log 6 raised to the power of x is equals to log 12 over 7. But from the property of logarithm, we have that if we have log a raised to the power of b, this is equals to b log a, and if we have log a over b, this is equals to log a minus log b, right? So applying this to this equation, we have this to be x log 6 is equals to log 12 minus log 7. Alright, so at this point, we want to divide both sides by log 6. So divide both sides by log 6. So this is going to cancel out this. We have that x is equals to, so this can be written as log 12 over log 6 minus log 7 over log 6. Alright, so from here we know that, but we can easily write 12 to be 6 multiply 2. So this is going to become x is equals to log 6 multiply 2 over log 6 minus log 7 over log 6. But from the property of logarithm, we have that log a multiply b is equals to log a plus log b. So applying this right here, we have that x is equals to log 6 plus log 2 all into log 6 minus log 7 all into log 6. So separating this, we have this to be x is equals to log 6 over log 6 plus log 2 over log 6 minus log 7 over log 6. But from the property of logarithm, which is the change of base formula, that says that if we have that log a over log b is equals to log b of a, right? So this is it. So applying this, we have this to be x is equals to log 6 cancel log 6, this is going to be 1, plus applying this change of base formula to this is going to become log 2 base 6 minus, if we apply this right here, this is going to become log 7 base 6, and this becomes the final value for x. So guys, the next thing we want to simply do is to simply verify if our answer right here is correct. So to verify, we have the question to be 6 raised to the power of x plus 2 minus 6 raised to the power of x is equals to 60. And we have that x is equals to 1 plus log 2 base 6 minus log 7 base 6. So this is the value for x. So from here we have this to be 6 raised to the power of 1 plus log 2 base 6 minus log 7 base 6 plus 2 minus 6 raised to the power of 1 plus log 2 base 6 minus log 7 base 6 is equals to 60. Now applying the law of exponent that says a raised to the power of n plus n is equals to a raised to the power of n multiply a raised to the power of n, and also we have that a raised to the power of n minus n is equals to a raised to the power of m over a raised to the power of n. So applying this right here, we have this to be 6 raised to the power of 1 plus 2 is 3. So we have this to be 6 raised to the power of 3 plus log 2 base 6 minus log 7 base 6 minus 6 raised to the power of 1 plus log 2 base 6 minus log 7 base 6 is equals to 60. So applying this exponent property right here, we are going to have, so applying this, we have this to be 6 raised to the power of 3 multiply 6 raised to the power of log 2 base 6 all into 6 raised to the power of log 7 base 6 minus 6 raised to the power of 1 multiply 6 raised to the power of log 2 base 6 all into 6 raised to the power of log 7 base 6, and this is equal to 60. But we know that from the from inverse property of logarithm, we have that a log ab is equals to b. So from here we have that 6 raised to the power of log 2 base 6 is equal to 2, and we have that 6 raised to the power of log 7 base 6 is equals to 7. So applying this right here, this is going to become 6 raised to the power of 3 is 260 multiply 6 raised to the power of log 6 2 is equals to 2, so which is 2 over 6 raised to the power of log 7 base 6 is going to give us 7 minus 6 raised to the power of 1 is 6 multiply 2 over 7 is equals to 60. So right here we have 216 multiplied 2 is going to give us 432 over 7 minus 6 multiplied 2 is 12 over 7, which is equal to 60. And from here we have this to be 7, and this is 432 minus 12 is equals to 60. So 432 minus 12 will give us 420 divide 7 is equals to 60, and 420 divide 7 is going to give us 60, which is equals to 60. And this is to show that our answer for x is actually correct. So right here we can easily say that the value for x is equal to 1 plus log 2 base 6 minus log 7 base 6. So this is the final answer.